Rivers and streams will be closed in Yellowstone National Park, and Gibbon River will be closed today from 2 p.m. to sunrise. Due to the high heat today, water temperatures are exceeding 68 degrees.
That is a supervolcano that would have consequences not for the United States, but for the entire world.
A hydrothermal explosion happens when extremely hot water trapped under the Earth's surface converts to steam.
Something terrifying is waking beneath Yellowstone. In just months, scientists discovered over 86,000 hidden quakes, unexplained hydrothermal explosions, and an eerie blue pool that appeared overnight. Could this be the start of Yellowstone's reawakening?
Yellowstone, the very name conjures visions of vast, untamed wilderness, prismatic hot springs glowing in unlikely colors, bubbling mud pots, geysers erupting against cobalt skies. Yet beneath these rolling valleys and clusters of old-growth pine, a world exists that few have seen or even imagined, a restless domain of hidden tremors, boiling water, and ancient tension. Millions have come to gaze on the park's wonders, oblivious to the powerful secrets moving just beneath the crust. But in recent months, a series of discoveries have shocked the scientific community and redefined our understanding of America's most volatile landscape. A flurry of invisible earthquakes, the appearance of a newborn thermal pool, and the revelation that what lies beneath our feet is anything but silent. What is stirring Yellowstone back to life? In the deep of winter, stretching from December 2024 to February 2025, something remarkable unfolded in the Norris Geyser Basin. Overnight, shimmering blue pools appeared, a brand new hot spring, serene and almost otherworldly, would soon draw the attention of geologists worldwide. 13 feet across, pale as glacier melt and dangerously hot, it was the latest sign that the geyser basins are still alive, reshaping themselves beneath the frozen air. And this was just what the eye could see. Below the surface, AI-powered seismic analysis was changing everything. Scientists have unearthed evidence of more than 86,000 previously unrecorded earthquakes, a swarm of activity that upends decades of assumptions and redraws maps of Yellowstone's hidden movements. Delving into the park's rock layers, geologists have even identified a previously unknown geological unit in the park's west, a piece of ancient history, its origin a mystery. Beneath it all, hydrothermal explosions, equaled in force to the might of an atomic bomb, lurk, biding their time behind clogged passageways and mounting pressure. And so scientists grapple with the question, are these mysterious signals, repeated explosions, and the swelling pressure signs of ordinary geological flux? Or do they hint at something far more profound in motion below the caldera? Step into a place where tranquility hides deep uncertainty, and every whisper from the depths shapes our understanding of power, risk, and awe. For Yellowstone's story is one of mystery, unfinished, and never predictable. The Tremors Unveiled, Yellowstone's hidden earthquakes. For generations, Yellowstone's seismic patterns have seemed both familiar and manageable. A handful of tremors flickered through the valleys, small clusters of quakes breaking the long silences of ancient stone. Geologists charted these disturbances with primitive instruments or their own careful observations, believing they had a reasonable grasp on the park's pulse. But every scrap of data and hand-drawn map has been eclipsed by a technological leap, AI-driven research that has uncovered an astonishing 86,000 previously undetected earthquakes beneath Yellowstone. The magnitude of this discovery is hard to overstate. Unlike earthquakes that rattle windows or make headlines, these events were subtle, unfelt, invisible, and previously lost in the noise of seismic data. AI, analyzing archives with unmatched sensitivity, identified tiny shifts deep below the surface. These weren't merely random. They represented a hidden choreography, a symphony of tiny shakes as the Earth released its stresses in countless incremental steps. The implications are immense. What does it mean that so many earthquakes were hidden from view for so long? Rather than a dormant giant, Yellowstone emerges as a landscape humming with constant motion, a restless network of stone and magma in endless conversation. Each microquake is a message, a faint transmission from the depths, sometimes clustering in swarms near geyser basins like Norris or Porcelain. These swarms often follow puzzling patterns, picking up and slowing down, as if the ground itself was responding to shifting pressures or pulses from beneath. The realization invites caution. The region's seismicity is far more complex and active than simple tremor catalogs once suggested. Scientists now comb through these findings, searching for meaning in the patterns. Do swarms of small earthquakes foretell more substantial unrest, or do they harmlessly vent the system, reducing overall risk? The answers remain uncertain, but the message is clear. Yellowstone's foundation is alive, never still, and our understanding must be both humble and vigilant. Each quake, no matter how faint, is a reminder of the vastness of the mechanisms at play and the value of listening with ever more sensitive tools. Yellowstone's beauty, nature's warning, the birth of a new thermal wonder. The Norris Geyser Basin has always been a lesson in unpredictability. Here, sulfurous vapors twist upward, and the very ground seems ready to shift beneath your feet. Even so, the basin's habit of revealing new wonders still manages to astonish. Between late 2024 and early 2025, when winter snows reduced visitor traffic and muffled the usual bustle, scientists observed the sudden appearance of a new feature, a hot spring glowing with a pale blue intensity. This pool, spanning over 13 feet, materialized on the heels of months marked by unusual hydrothermal explosions, small, violent spurts that cracked open the crust and transformed the surrounding terrain. Its color, a surreal cyan, is owed to the clarity and temperature of the water, refracting light in a way unique to freshly opened springs. Researchers moved quickly, mapping the pool's dimensions, monitoring its temperature, and sampling its mineral-rich waters. Here, in an instant, centuries of accumulated sinter and routine had been disrupted. Beneath its tranquil surface, however, are signs that the quiet birth of such features is anything but random. The explosions that preceded it, subtle and not widely publicized, rattled the ground quietly but decisively. Did they relieve mounting pressure or signal deeper blockages and accumulated tension yet to be resolved? The answers remain subject to study. Park authorities responded quickly, marking new danger zones and assuring visitors' safety, while geologists raced to update maps long considered settled. To witness a hot springs formation in real time is to be confronted with the volatility at Yellowstone's heart. Every new feature is a stark indicator of the system's restlessness. It prompts questions. Is this emergence merely a quirk of local chemistry and chance, or is it another note in a larger pattern, a surface sign of deeper processes that occasionally force their way into view? The unfolding story keeps scientists alert and underscores the need for meticulous observation. Yellowstone's surface is a living palimpsest, rewritten with every new vent and spring, challenging our understanding and our caution. A clogged system and hydrothermal fury. Yellowstone's summers usually draw crowds seeking the spectacular. Old Faithful's relentless eruptions, plumes of steam, and bison grazing along hot creek beds. Yet nature rarely keeps strictly to the expected. Last summer, a dramatic hydrothermal explosion caught scientists by surprise and forced a new reckoning with the park's underlying danger. The U.S. Geological Survey traced the root cause, a clogged subsurface plumbing network. For years, minerals precipitating out of Yellowstone's superheated waters deposited themselves within cracks and fissures. These slowly accumulating plugs, invisible to all but the most specialized instruments, eventually blocked the flow of boiling water. Pressure increased, held back by these clogs. In time, the weakest point broke, resulting in a violent explosion. Rock, water, and steam hurled skyward with the force measured as comparable, at least in the context of natural energy release, to powerful explosions. While hydrothermal explosions have shaped much of Yellowstone's recent landscape, their unpredictability keeps both scientists and visitors on edge. Unlike volcanic eruptions, they do not herald themselves with clear warning. Their precursors, rising ground temperature, bubbling, ground cracking, small precursory quakes, often go unnoticed or are too subtle to provide meaningful forecasting. The lesson is sobering. Yellowstone's hydrothermal system is dynamic and dangerous. Its beauty is underwritten by the same instability that can, without human intervention, lead to catastrophic change. This dramatic event was not an isolated anomaly drawn from myth, but a recurring theme in Yellowstone's history. Every tranquil pool or geyser hides a potential for sudden transformation. Scientists, in response, continually monitor hotspot activity and historic explosion craters. By mapping mineral deposition, seismic patterns, and water chemistry, they hope to refine their understanding and catch signals early. But the clear fact is that no current technology guarantees advance warning for these most violent manifestations of Yellowstone's power. The uneasy truth remains: temporary stability in Yellowstone can mask the development of potentially dangerous forces. Clogs in the hydrothermal network can be relieved quietly through small releases, or, rarely, but memorably, by sudden, explosive events that remake the landscape in an instant. Discoveries in the depths, new units, and ancient warnings. Yellowstone's riches are not all found at the surface. Its mountains, forests, and valleys blanket a stratified history of ancient eruptions, lava flows, and cataclysmic violence. In recent years, geologists from Montana State University have uncovered evidence of a new geological unit tucked into the park's western regions, a sequence of rock distinct in its composition, previously unrecognized among the park's complex layers. The significance of this discovery is still unfolding. Each geological unit helps researchers reconstruct the timeline of Yellowstone's enormous volcanic system, revealing not just what happened, but how and when various forms of heat and fluid moved through the earth. The new unit's chemical signature, its mineral content, embedded crystals, and patterns of deposition suggests it formed during a period of the park's history that has, until now, been poorly understood. Could this unit be associated with a past hydrothermal explosion, a period of heightened volcanic activity, or a unique pulse of water and magma ascending from the underworld? The answers require further study, but even tentative identification demands revision of maps and models that shape how scientists understand the park's risk profile. Each newly discovered rock layer opens fresh questions about the potential for future unrest. Maybe it marks an era of intense explosions. Maybe it reveals how heat, magma, and volatile gases have moved in ways not previously suspected. Regardless, the find is a powerful reminder that much of Yellowstone's history remains cryptic, contained in stone, only now coming to light. For those who study geological disaster and risk, understanding the past is a direct means of forecasting the future. Yellowstone's landscapes testify to cycles of creation and destruction, processes which can reawaken without warning and whose records remain incomplete. Superheated warnings, the explosive legacy of Yellowstone. To walk the boardwalks along Yellowstone's springs and geysers is to step through the remnants of ancient violence. Many of the craters, ravines, and strange scars found across the park are the legacy of previous hydrothermal explosions, geological events that can excavate massive pits and hurl boulders across the landscape. These are not fairy tales. The last few centuries have seen dozens of significant explosions, though none have reached the calamitous scale of truly catastrophic events in Yellowstone's geologic record. Beneath the surface, water percolates through fractured rock, heated by magma to temperatures far above boiling. When an impermeable layer or mineral plug blocks escape, pressure mounts silently until an abrupt failure triggers an explosion. But historic and geological evidence shows that the largest among them could approach the scale associated with powerful bombs. Scientists are determined to learn from these well-documented explosions, noting that while the system can remain stable for decades or centuries, the right combination of pressure, heat, and blockage can override even the park's self-regulating tendencies. Studies of explosion craters reveal layers upon layers of debris, cataloging a repeating cycle of calm and chaos. The presence of new springs, the arrival of thousands of previously undetected earthquakes, and the discovery of uncharted rock all point to the unending dynamism at the park's heart. At the same time, the rarity of supersized explosions offers reassurance. Yellowstone has endured for millennia, weathering cycles of activity. It continuously reshapes itself, venting steam, opening new springs, and shifting ground, instead of bottling up energy for a single titanic release. Yet, all these findings serve as a caution. In a place where tiny changes below can trigger enormous effects above, the line between equilibrium and violence is always thin. Science and story: how humanity meets the unknown. Cataloging events at Yellowstone is a scientific necessity, but interpreting their greater meaning is a human imperative. Each newly discovered unit of rock, each blue hot spring or cluster of hidden earthquakes is as much an invitation as a warning, a call to watch, listen, and try to decipher patterns that have developed over geological lifetimes. The discovery of an entirely new geological layer, for example, forces a revision of established history. Scientists pore over mineral signatures and layers of ash, recasting hypotheses about how the caldera has evolved over the eons. The 86,000 newly discovered earthquakes demand reconsideration, prompting research into how the ground in Norris Geyser Basin, Porcelain Basin, and other areas is truly behaving beneath the surface. Researchers simulate the underground flow of water, magma, and gas, running models with new data to identify possible stress points and how future changes might unfold. Advancements by Rice University and other teams using ground-penetrating imaging and cutting-edge AI are uncovering how the crust bends, how the magma exerts its pressure, and how the complex web of channels adapts in near real time. Meanwhile, seasonal fieldwork by park geologists, tracing the edges of new hot springs, testing unknown minerals, mapping shifting trails, cements the connection between sudden events and slow, ongoing transformation. For rangers and visitors, the park remains a place of inspiration, but also a realm demanding respect. Every new warning sign, every realignment of boardwalks, reinforces a larger lesson. The publicly visible wonders of Yellowstone rest atop an ever-changing and sometimes unpredictable foundation. As the debate continues, some experts highlight the park's remarkable record of dissipating energy through small-scale eruptions and explosions, pointing out that disaster is avoided by the routine venting of pressure. Others see the accumulation of new features and shifts as indicative of the system's instability, a reminder that no one is immune to surprise when it comes to the world's most famous supervolcano. What's undeniable is that Yellowstone's complexity outpaces even our most sophisticated understanding, requiring the humility to revise and refine in the face of new discoveries. A world reframed, the promise and peril of listening. The latest discoveries at Yellowstone are not just scientific advancements, they're a profound reminder of the privilege and challenge of paying attention to the Earth's subtler signals. With each new blue pool, every concealed earthquake, and each rock layer unearthed, technology extends our senses, revealing patterns beneath a landscape thought to be so well understood. What might remain hidden elsewhere, beneath ocean basins or deep in remote forests? If Yellowstone, among the world's most studied parks, continues to deliver revelations, it prompts humility in explorers and scientists across the planet. New features and phenomena are no longer only academic curiosity, they are signposts of the Earth's capacity for renewal and abrupt change. These events reverberate culturally too. Writers, artists, and musicians respond to Yellowstone's drama, turning seismic data into music or painting the emergence of new hot springs as symbols of hidden power. Educators use these moments to remind younger generations of humanity's need to balance awe with vigilance, a call to view our relationship with the natural world as one based on both appreciation and preparedness. At Yellowstone, the synthesis is clear. Data and mystery are not opposites, but partners, with each new discovery underscoring the point that science is as much an art of interpretation as it is of measurement. AI-driven research does not merely collect numbers, it helps frame the right questions, offering a deeper sense of respect for the planet's unpredictable processes. A hidden messenger, Yellowstone's final word. In the end, what unsettles is not only what is visible, but everything now revealed to be possible. Yellowstone, this landscape of steam, stone, and fire, has once more upset the balance of certainty, unveiling mysteries encoded in numbers, rock, and eruptive force. The sudden emergence of a light blue spring in Norris Geyser Basin signals an ongoing story. Yellowstone is a place continually in the process of remaking itself. 86,000 hidden earthquakes add urgency to the notion that tranquility may be far more complicated than it appears. The park's hydrothermal systems, subject to both sudden blockages and dramatic releases, are a vivid reminder that apparent stability can mask powerful, unpredictable dynamics. And every new geological unit, whether formed in violence or gradual transformation, is another chapter in a tale whose end we may never see. For scientists, the message from these recent findings is as clear as it is humbling. We are guests above an engine of immense and shifting power. Yellowstone's signs, be they blue hot pools, seismic clusters, or ancient rocks, invite careful listening rather than complacency. To stand above Yellowstone's depths is to experience the constant negotiation between energy and resistance, creation and oblivion. The park's gentle surface betrays nothing of its endless negotiation below. Awareness, preparedness, and reverence are the only reasonable responses to this captivating uncertainty. As this new age of revelation unfolds, our duty is to attend carefully to the Earth's evolving messages, neither panicking nor ignoring them, approaching Yellowstone's changing landscape with vigilance, with gratitude, and with awe. If Yellowstone's latest discoveries surprised you as much as they did us, consider sharing your thoughts. Our world is full of secrets, and sometimes what emerges from the depths is both more terrifying and more enchanting than anything we could have imagined. Stay curious, stay attentive, and remember, the Earth is always speaking. Will we continue to listen?